All right, so I hope you have tried to solve these two tutorials. Okay, I gave this tutorial in Google Classroom yesterday. I uploaded this in Google Classroom yesterday. So I hope that you have tried to solve these questions. Okay, let me have a look. Tutorial 4. Okay, all right. So this is a question for tutorial 4. Is there any concerns? Is there any questions related to tutorial number 4? So tutorial 4 basically discussing about the properties of a transform. So basically these topics for tutorial 4 covered in lecture 10 and lecture 11, yeah, the properties. So any questions on this tutorial 4? Okay, so there's a questions by David Ong. Question 1, how to transform it into xt? Let me see, yeah. Question 1. Is this the one, right? Okay. You don't have to transform into the xt. So the question asks you if you are given full transform of the xt, which is given by this x omega, what should be the full transform for this xt or these functions? Yeah. Okay. All right. So if you base on these questions, I think it's quite straightforward. Let me try to solve. Try to. Okay. Let me see here. Anything that I can do here? Okay, I can do a comment. Okay, so for this particular case, yeah, let's say we are having I try to connect my tab, yeah. Please be patient. Please hold on for a while. Sorry for this. I need to use, let's say, if I can use a Jamboard. Oh, it's not connected. Sorry. Got a problem with my tab here. It can't be connected. Sorry for this problem, yeah. Okay. Now I can do it using this. Okay, let's go back to this case. Right, see what can I do here. Okay, good. Right, so for the first case here, where we have a x of negative 2t plus 1. So basically this is to be based on the properties, yeah, of the Fourier transform. So can you view the tutorial 4 clearly? Okay, good. Thank you, David Ong, for your reply, and Omar. Okay, this is the one, yeah. Okay, so we know that from the properties of a transform, we know that if we have the xt time domain, so the Fourier transform for this will be equals to x omega, right? Which x omega is given by these terms. So if you base on this number 1 of part A, you have two operations. We always proceed with the time shifting. So xt plus 1. So if we transform for this, will give us x omega of exponential of j omega. Huh? Okay, because your shifting constant is 1, so you're going to have e j omega. Supposedly it should be t naught here, but since we have a constant of 1, so it should be j omega. And then we have a time scaling of -2. Okay, so for transform for this will be equals to 1 over 2, okay, modulus. Okay, and this will give us negative omega divided by 2, exponential of negative j omega divided by 2. Right, so basically you're going to have, the answer will be 1 over 2, okay, x of negative omega divided by 2, exponential negative j omega divided by 2. So we just use these x omega terms, in which we just substitute all the omega in this equation, or in these terms here, to be just equals to omega divided by 2. So supposedly the answer will be we're going to have half, okay, and this will be equals to omega divided by 2 squared plus j4 of negative omega divided by 2 plus 2 divided by omega divided by 2 squared plus j of 4 negative 4 omega plus 3. Sorry, I make a mistake. Sorry for that. Yeah. Okay, so it's supposed to be negative omega divided by 2. Okay, and then need to be multiplied with this exponential of negative j omega squared. So I just put it here, exponential negative j omega divided by 2, multiply with all of these terms. Okay, is that clear on this answer? So basically it's just to test your understanding on the properties of a transform, which is including the time shifting and time constant properties. Yeah. Okay. Any questions? Any question on this? Is that clear on this solution? Hopefully you understand this clearly. Okay. Any more question for this particular tutorial one? I mean, question number 1. Is there any question? Question 1 for tutorial 4. Okay, it's clear, yeah? Okay, good. So let us proceed with question number 2. Is there any concern on this question number 2? I prefer if you can voice out your concern, yeah, because I cannot go through the chat, because I'm now concentrating on this page, so I cannot refer to this Meet page. Yeah, so if possible, if you have any question, please voice out. Better for me to respond to your concern immediately. Any question for the 4? Question 2 now. No concern for question 2? Clear?
Doctor,
Yeah.
I want to ask the question to see how to do.
This question is it for
Uh,
cos 2t? Okay. All right. So for this particular case, okay, given the questions, we have a time domain of exponential negative modulus t, and its Fourier transform is given by 2 over omega squared plus 1. Okay, but in this particular case, you are given 4 cos 2t, divided by t squared plus 1, in which if we can compare the given transformation and the questions here, somehow we can see a pattern, the same pattern somehow, but the pattern is for the given information is in frequency domain, but the question is in time domain, yeah? Yeah, we have omega squared plus 1, and here we have t squared plus 1. So based on this, we can use the properties that we have learned before, which is a duality properties, yeah, duality properties. So if we can refer back to the duality properties, so duality might state that if we have, xt, which will give us x omega. Okay, so the duality state that if we have same pattern with these terms in frequency domain, so its Fourier transform will be 2 pi of x of negative omega, in which this is equivalent to this in terms of the pattern, and this is equivalent to this in terms of its pattern, yeah? Okay, so we have to apply the duality properties to solve for these questions, yeah? Right, in which if you base on this, from exponential negative modulus t, so this will give us 2 over omega squared plus 1. So as such, we can have 2 over t squared plus 1, and this will give us 2 pi of exponential negative omega. Right, yeah? Because we're negative here, right? So, but since we have a modulus, so we can cancel negative, so we're going to have modulus of omega, just like that. Okay, hopefully you understand about this concept. Okay, then we have 4 cos 2t of t squared plus 1. So from here, I can write that if we have 4 of t squared plus 1, so Fourier transform is simply 8 pi, sorry, 4 pi, I apologize, that's my mistake then. Okay, it should be 4 pi. Okay, it should be equals to, because we multiply with 2, right? We multiply with 2, and this should be multiplied with 2 also, based on linearity properties. We're going to have 4 pi exponential of negative omega. Okay, and since we have a multiplication with the cosine of 2t, so this should be based on properties of modulation. Yeah, so from here, when we have 4 over t squared plus 1 multiplied with cosine of 2t, so Fourier transform for this will be equals to 4 pi divided by 2. So modulation state that they will have negative omega minus 2 plus exponential negative omega plus 2. Okay, so that should be the answer for part C. So first thing, you have to apply a duality to find a Fourier transform for 4 over t squared plus 1, where we have it equals to 4 pi exponential negative omega. And after that, we need to consider the use of modulation properties. And we have a multiplication with cosine of 2t. So we're going to have a half, supposedly, yeah, half exponential negative omega minus 2 plus exponential negative omega plus 2. So we have a 4 pi there. Okay, is that clear on the solution for question 2C?
Yes, yes, Doctor.
Okay, thank you very much. Yeah. How about question 2A and B? So I think B and C is almost the same, because for B also you need to use duality properties plus linearity properties. And I think for A should be no problem because this is based on differentiation. Yeah. Okay, so I think we have done with this. Can say the question of part. If I need to cancel this one. Yeah. Okay. For part question 2, I think it's clear. You have understand it clearly, hopefully. Yeah. And for question 3 now, is there any question? Is there any concern related to question 3? No question on question 3?
Yes,
Okay,
Doctor. Question 3.
question 3, yeah? Okay, question 3, you need to find a full transform for yt, okay, by using a differentiation and time shifting properties. So I think it's good if I can use the gem board or whiteboard because it will need quite a lot of spacing to discuss about these questions. Yeah, so allow me to change the whiteboard now. Okay. All right. So you can refer to your questions. Yeah. Okay, this is the one. We're going to use the gem board to discuss about these questions. Okay. Right. So we are having a YT, which is given in terms of straight line. Yeah. Yeah. See if I can sketch it again for you here. We are given. Okay. This is your YT, and somehow it looks like this. Okay. This is located at -4. This is at -3. This is at 3 and this is at 4, and it is located -4 of y and +4 of y. Okay, so the question asks us to find what should be the Fourier transform for the yt. Yeah, that should be the question asked. Yeah, what is the Fourier transform for this particular signal? So, and it's given a hint here that you can use a differentiation and a time shifting properties. Okay, so the question is, you have the yt. Yeah, you have the yt in time domain, so you need to find out what is your y omega. Yeah, so this is the thing that need to be obtained based on the questions. Okay, so when we apply a differentiation properties, we need to differentiate this graph. Okay, so if we differentiate by first order differentiation, okay, what should be obtained? Okay, just say this is d yt over dt. Okay, so supposedly if we differentiate, because it's straight line, right? And the slope for this line is, okay, let's write the slope. The slope for this is equals to, m is equals to -4. Okay, that's the slope. And for this line, the slope is m equals to positive 4 divided by 3. So, yeah, 4 divided by 3. And for this line, it is m slope of equals to -4. Okay, that should be the slope value. So from this given slope, I mean from this obtained slope, we can then write that for differentiation for yt, we are supposed to get just a constant value between -4 and -3, in which it is a constant of -4, supposedly. Okay, -4, that should be the constant value when we differentiate this line, constant -4. And then from -3 to +3, when we differentiate this line, we are going to have a constant also, and the constant value is 4 divided by 3, yeah, because of the slope value. And the same thing is applied between 3 and 4. When we differentiate this line, we are going to have a constant value of -4, which is similar to what we have earlier. Okay, that should your dyt over dt. So when we try to use a differentiation to find a full transform, we always try to differentiate until we arrive or until we meet an impulse function. And that's the rule in differentiation properties. Yeah, I repeat again, if you want to apply a differentiation properties in Fourier transform, you need to differentiate until you meet or until you arrive up to this impulse function. So since in this particular case, we are yet to arrive to impulse function, so there is a room for further differentiation. So we shall proceed with the second order differentiation now. Okay, so for second order differentiation, we're going to have this is d squared yt over dt squared. Okay, so if we differentiate this step. Yeah, this is about step from from 0 to -4. So at -4, we are supposed to get a negative impulse having a -4 amplitude. At -3, you can see that there is an impulse from a step from -4 to +4/3. So that should be a positive impulse. So the amplitude will be a difference between this value -4 and 4/3. So supposedly going to have 16/3. Yeah, that should be the amplitude for this impulse. Then at +3, again, we're going to have a step down movement, which is from 4/3 to -4. So you are going to have an impulse of a -16 divided by 3, so it's going down. And then at 4, we are going to have a positive impulse because the step is moving from -4 to 0. So that should be the impulse of 4. Right, so that should be the results of your second order differentiation, in which we have reached up to these impulses. Yeah, and from here we can proceed with finding the Fourier transform for the yt, which has been requested. Yeah, have been required from the questions here. Okay, and since we have a second order differentiation, right? So by using a properties of differentiation, we know that if your yt is given by, a Fourier transform is y omega. So if we have a second order differentiation, d over dt squared of yt. Okay, sorry, it's not that sensitive. Okay, so the Fourier transform for this will be equals to j omega squared. Okay. What happened? Okay. Okay, so for this, we are going to get j omega squared y omega. Okay, that should be the case, right? This is based on what we have learned previously in a what you call that, in a differentiation properties. Yeah, right. So supposedly that should be equals to negative omega squared of y, of y omega. Okay, that should be the case. Right, so allow me to go back to this PDF file of the tutorial. Okay. Right, so from what we have obtained just now, when we have d squared of yt over dt, it is consists of 4 impulses. If we can write based on what we have obtained before, this equals to -4 of a delta function t plus 4 plus 16/3 impulse function of t plus 3. Okay, and then we have a negative impulses, -16/3 impulse function t minus 3 plus 4 impulse function of t minus 4. Okay, so this is what we have obtained, okay, based on this differentiation that we have done. So from here, we can see that in terms of its Fourier transform, okay, when we did a Fourier transform, we're going to have negative omega squared of y omega, okay, right? And this should be equals to, yeah, because all of these need to be transformed into a Fourier transform in time domain, right? So we need to transform into Fourier transform. So you can refer to the table, yeah, in which we are supposed to get, for the first terms of negative 4 delta t plus 4, it should be negative 4 exponential of j4 omega. Okay, for the second terms, it's supposed to be equals to plus 16 over 3 exponential of j3 omega. And for the third terms, going to have negative 16 over 3 exponential of negative j3 omega. And for the fourth terms, it's supposed to be 4 exponential negative j of 4 omega. So that should be your results. I mean, this is your Fourier transform for these time domain functions. But this is yet to be our answer, because remember the question is to find the y omega. So from this relationship, you can find the y omega straight away, in which you can bring this negative omega squared to the right hand side. So you're going to have y omega will be equal to negative 1 over omega squared, and everything here should be putting in the bracket. So that should be the answer for your y omega. Okay, right. Hopefully it's clear on how to use a differentiation and also time shifting properties as requested from this question in finding the Fourier transform of the yt. So remember, in implementing or in doing this differentiation for the Fourier transform, always differentiate until you meet the impulse function. That should be where you stop your differentiation step. Yeah. Right. Any question for question 3? Any concern? Is this clearly understood? Question number 3.
Yes, thank you, Lambutan.
Welcome. Okay, so if there's no question for question number 3, I think we can proceed now with question number 4. Okay, let me cancel this one first. All right. So number 4. Any question for question number 4? Sorry, I prefer to use PDF file then, because using the whiteboard, I got a delay in my handwriting. I'm not sure why. So it's convenient for me to use this PDF instead. Okay, number 4. Is there any questions on question 4?
Yes, Dr. Part B.
Which one? Question 4?
Yes, Doctor.
Question 4A or question 4B?
B, Doctor.
B.
Part B.
A should be okay, is it?
Yes,
Okay,
yes.
so I think since you did mention okay to me for part A, so I should proceed with the question B straight away. Okay, so this is to, okay, yeah, we given the xt. Okay, for I think for part A is similar to what we have done in question 3. So I think it won't create any problems, but you have to be very careful, yeah, for this xt, because when we differentiate this xt, yeah, you are going to have a constant when we differentiate the xt, a constant between negative 4 and 0. Yeah, a constant, because if I can sketch this for you, sorry, yeah, just very short, just for information. So when we differentiate it, okay, this is your dxt over dt. Okay, you're going to have from negative 4 to 0, you're going to have a constant, yeah, a constant of positive half, because the slope is 2 over 4, so m equals to half. The same happened to this, m equals to half. So again, from 0 to 4, also going to have a half constant. But you have to be very careful that from this 2 to negative 2, there's a step, yeah? There's a step changes in which you're supposed to have, when you differentiate at 0, going to have an impulse here, which is at a 0 with the amplitude of -4. Okay, so you have to be very careful on this, yeah? At 0, when you differentiate the xt, there should be an impulse in which the amplitude for that will be equals to -4, yeah? Right, so I think the rest should be okay lah, yeah? Because once you have obtained the dxt over dt, you can then proceed with the differentiation. But since we have differentiate up to a impulse function until you meet the impulse function, so you cannot differentiate anymore. Yeah, so we shall stop for the first order differentiation. Yeah, we cannot proceed with the second order differentiation because for the first order we have arrived up to differentiation. We have arrived up to the impulse function. Okay, I think it's clear on this. So let us proceed with the question B as requested just now. Okay, this is just to sketch the signal of yt if your x omega have been transformed to the following operations or transformation. You are given that y omega is x omega exponential of negative j omega. So, okay, sorry for that. Right. So if we, based on this question number 1, okay, we're going to have that we need to do the inverse Fourier transform, yeah? Okay, basically it's to do the inverse Fourier transform because we need to find the yt. Okay, so based on that, we can deduce that yt basically shall be equals to xt minus 4, supposedly. Am I right? Because we have this exponential term. So refer back to these shifting properties. If we have xt, which will give us x omega. So if we have xt minus a, so Fourier transform with x omega exponential negative j omega. So this is based on the Fourier transform properties of time shifting. So since we based on this, we have x omega exponential negative j4 omega. So it's clear to us that the shifting value is equals to 4. That's why we have yt equals to xt minus 4. So this is just based on the shifting of xt. So you need to shift this xt by 4 units to the right. Okay, so I don't think I have to do this for you. So you can do this on your own. Xt shall be shifted by 4 units to the right. That should be the yt, yeah? Okay, and for the part 2 of the questions, this one. So if we base on these questions carefully, when you do the inverse Fourier transform, so you are supposed to get yt shall be equals to x of t divided by 4 minus 1. Okay, right, because, okay, now I'm going to use this again. So let's say I have xt over b minus a, yeah? So going to have what? Going to have 1 over b, okay, x over omega 1 divided by b, okay, this is omega, yeah, and exponential of negative j omega a divided by 1 over b, which will give us b of x, b omega, exponential negative j omega a b. Okay, so based on this, we can say that your b equals to 4. Okay, when we compare this and this, you're going to have b equals to 4 supposedly, and your a shall be equals to 1. So that's why we have this as xt over 4 minus 1. Right, hopefully it's clear, yeah, why we have t over 4 minus 1. So again, to sketch the yt, so I think we have done this in chapter 1. Yeah, shift it first and then do the scaling, yeah. Right, that's done for question 2. While for the question 3, this is a combination of two signals. So this should be equals to the inverse Fourier transform. This will give us yt. This should be give us xt, and this should be giving us xt minus 4. Okay, so this is operation of signals. So you have to, this is your xt. So you have to minus xt, which has been shifted by 4 units to the right. So basically you're going to have two signals. This is the first one, the xt. Another one is shifting to the right. So that should be look like this. Sorry, okay, and okay, in which this is 8 This is 12. Okay, this is 2 and this is negative 2. So this signals is xt, while this signals here is xt minus 4. Okay, so it means that you have to do the arithmetic operation xt minus 4. Okay, so I hope you can try to do this on your own. Sorry, I think it's my mistake. I apologize. Sorry for that. I think I made a mistake. Not this one. This is not the xt minus 4. Sorry. Sorry, yeah, it's my mistake. Okay, it's supposed to be the signals. Okay, all right, that's the one. Sorry for that. Okay, to 8. That. Okay. Right. Okay. Right. So this is your xt minus 4, yeah? Right. So just do a arithmetic operation. You have to subtract xt and xt minus 4. So hopefully you can try to solve this on your own, yeah? On subtraction of the signals. Okay. So that's done with tutorial number 4. So by this, I hope that you have clearly understand the properties of a transform, yeah? Okay. Any question on tutorial number 4 so far?
Clear, sir.
Clear, yeah? Okay, good. How about others? Um, no response from others. Are you in the class or?
Yes, doctor.
Okay, right. Just my concern only, yeah. Right. So I think you have done tutorial number 4. We shall now proceed with tutorial number 5. Yeah. Tutorial 5 is on application of a transform, which has been learned yesterday, right? Sorry for any problems during our class yesterday. Okay. Sorry. Right. I shall now proceed with tutorial number 5. I think you have been given these tutorial questions, which is on the application of a transform. So basically, it's just 2 questions, and for information, the questions that I give to you in this tutorial, basically, like I say, both of them are the previous test questions, the previous test and final exam questions. So this is a standard of questions that we are going to have in our assessment, both test and final exam. Okay, so basically quite similar to what we have learned in class, in which we have I've taught you how to apply a Fourier transform in solving a problems related to the filters and also related to this modulation, amplitude modulation to be exact. Okay, any question on tutorial 5? Chiong Lai Si, can you hear my voice clearly? What is Chiong Lai Si? Ah, okay.
Yes.
Okay. You have any questions on tutorial number 5?
No.
Oh, no question at all. Yeah, very good, Chiong Lai Si. Any questions, guys, for number 5? So if there's no question, I think we can stop the session now.
Question 1, Doctor.
Question 1. Okay, to be exact, which one? Which part of the questions?
The second.
Second questions. Number 2, is it? Oh, okay.
Number 2.
Okay, number 2 is to, before you can answer number 2, you have to answer number 1 first. That's the problem, yeah. So I have to do this all the way from x1 omega, x2 omega, up to y omega. Then only you can find the yt. Because you need to find the y omega first, yeah. Okay. So basically, this is a modulation. Yeah, this is the question is related to modulation. Yeah, that we have learned in class yesterday. And the question is quite straightforward. Yeah, because we are given two inputs, which are the x1t and the x2t. And from these two inputs, you need to find AT. You also need to find the BT, and also you need to find the CT. Okay, and from these time domain functions, from x1t, x2t, AT, BT, and CT, you need to sketch all of these spectrum, the spectrum for all of these time domain signals, yeah, including the y omega or the Fourier transform for the yt. Okay, and then from y omega that you have obtained, then only you can find the expression or mathematical expression for the yt, in which the h omega is given here, and h omega basically is a filter, yeah, it's the filters. Okay, so if you base on this, and based on what we have learned yesterday, modulation and filters will exist simultaneously. Yeah, most of the time, the function for these two topics, I mean the modulation and filter, will exist simultaneously. So likewise, in this particular example, we have a modulation and we have also filters that exist together, these problems, yeah? Okay, so let us proceed with these questions. I think we need to answer the first questions here, which is to sketch the x1 omega and x2 omega. So we done, or we proceed with this question first, yeah? Which is the question first, these two questions, x1 omega and x2 omega, yeah? Okay, these two. Okay, let's have a look. x1t is given by 2 cos of 200 pi t, yeah? This is the one. So based on this Fourier transform, you can refer to the table, yeah? You can refer to the table of Fourier transform, that 2 cos of 200 pi t, okay, or it will give us, okay, 2 cos, okay, 2 cos of 200 pi t. So the Fourier transform for this, you can refer to the table. We're going to have equations of 2 pi of a delta function of omega minus 200 pi plus a delta function of omega plus 200 pi. Sorry for that. Okay, that should be the case. Okay, so that's going to have a two impulses located at 200 pi and negative 200 pi with the amplitude of 2 pi. So the same things happen for x2t. So x2t is given by 5 cos of 500t, 500 pi t. So if we have 5 cos of 500 pi t, so Fourier transform for this will be equals to 5 pi delta function omega minus 500 pi plus delta function omega plus 500 pi. Okay, so that should be your equation for transform. So from these two for transformation, you can sketch the x omega straight away. So x1 omega, okay, x1 omega, because we need to sketch, right? So we are supposed to get two impulses. We're going to have, the first one should be at negative 200 pi, and then at 200 pi. So we're going to have two impulses at having amplitude of 2 pi for both. Okay, this is for x1 omega lah. And for x2 omega, based on this equation here, you're going to have two impulses also, but located at negative 500 pi and positive 500 pi. The amplitude for both are 5 pi. Okay, so that should be your spectrum for both x1 omega and x2 omega. Okay, hopefully it's clear on this, yeah? All right then. So next one, we want to sketch for A omega. So before we can find the A omega sketching, we need to find the AT first, yeah? So based on this mathematical, maybe based on this diagram, we can write that your AT, okay, your AT here, okay, your AT is equals to x to t multiplied with cos of 1000 t. So it should be 5 cos of 500 pi t multiplied with cosine of 1000 pi t. Okay, this is the one. That should be the AT, yeah? Okay, so we need to write this AT in terms of a cosine function or addition of cosine function. Yeah, because we want to do the transformation of Fourier. So by using a identity, okay, identity which is cos, we have multiplication of two cos. Supposedly by using identity cos A, cos B, so we're going to have half of cos A minus B and cos A plus B. Okay, so that should be identity that need to be used in solving this part, yeah? So for that, we're going to have 5 over 2. Okay, so we're going to have cos of 500 pi t plus cos of 1500 pi t. Okay, so that should be a result of your AT based on the application of this identity. Okay, so based on this, your Fourier transform, the A omega, you're going to write this as 5 over 2, okay, and you're going to have pi, okay, delta omega minus 500 pi plus delta omega plus 500 pi, okay, plus delta omega minus 1500 pi plus delta omega plus 1500 pi. So we are going to have 4 impulses for this particular case, yeah? Okay, so impulses for A omega, okay, shall be looked like this. That should be the A omega. Okay, we're going to have 4 impulses located at the respective location based on the equation there. 500 pi negative, 500 pi positive, this is negative supposedly. Then we have 1500 pi, and we have at negative 1500 pi. So that should be the amplitude, which are constant or the same for all impulses. The value is 5 over 2 pi. So that should be the spectrum for your A omega, yeah? Okay. Okay, remember your AT, the time domain, because this will be used in finding the BT after this. The BT is a summation of XT and AT, yeah? So AT consists of two frequencies value, which is 500 pi and cos 1500 pi frequencies, yeah? Okay, hopefully it's clear on this A omega. Okay, so now we're going to proceed with this BT. Okay. Okay, so the BT, based on the diagram that we have here, it is equals to x1t, which is 2 cos 200 pi t plus with the ET, which has been obtained earlier, and that is equals to 5 over 2, okay, cos of 500 pi t plus cos of 1500 pi t. Okay, so this for this BT, we can straight away convert or transform into the Fourier transform, B omega capital. Okay, because the cos is standalone, for these three cos are standalone. So supposedly based on this, we are supposed to have 4 impulses, yeah, 4 impulses. Okay. All right, in which if we can proceed with this Fourier transform, you're going to have a 2 pi delta omega minus, omega minus 200 plus delta omega plus 200. Okay, that is for this particular 2 cos 200 pi t. And for this, we'll follow suit based on what we have obtained previously. You can refer to the previous sketching, yeah? So you're going to have 5 over 2 pi, I missed it. Okay, you're going to have 5 over 2 pi, okay, and that should be 4 impulses over there. Okay, so for the B omega, if I can sketch it here, okay, that should be your B omega. Okay, we're going to have 6 impulses located at negative 200 pi, positive 200 pi, then we have at 500 pi, and also at 1500 pi. The same things happen for negative side. We have at negative 500 pi and also at negative 1500 pi. Okay, so at 200 pi, the amplitude is 2 pi. Okay, whereas for 500 pi and 1500 pi, the amplitude is same as what we have done or obtained before, which is equals to 5 over 2 pi. Okay, that should be the B omega, yeah? Okay. Hopefully it's clear on the B omega, the spectrum for the BT. Okay, any questions so far? No, yeah? Okay, so there's no question. I think we can proceed to CT now. CT to be obtained, in which CT is multiplication of BT and cos of 10,000 pi t. Okay, again, this is a modulation. Okay, when we have a multiplication with the cosine function, it is said that BT is said to be modulated. Yeah, the BT is a signal which is said to be modulated by the cosine function, which will create or obtain, or which will produce a CT. Okay, so we can proceed now with the CT. Okay, so CT, based on this, CT, CT will equals to 5, is equals to BT multiplied, okay, going to have 2 cos 200 pi t plus 5 over 2 cos 500 pi t, okay, plus cos 1500 pi t, okay, and all of these need to be multiplied with cosine of 10,000 pi t. Okay, that should be the case. Yeah, it's quite long. It's quite long. Yeah, so based on this, we need to do a few operations that will be based on identity, right? Okay, so if we can proceed, so I'm going to proceed with the Jamboard because I don't have spaces, much space to be used here. So I refer to the Jamboard now. Although it will create delay, but this is the best that we can do. Sorry, yeah. Okay. Right. So for the CT, if you can refer back to what we have obtained just now. Okay. You're going to have your CT. Okay, you're going to have, it's quite a delay here. I'm not sure why. Okay, I think I can try to use Word lah. Hopefully, try to use Word. Yeah, try to use Word. Okay, yeah. Okay, what happened? Okay, we try to use we have a space down here, so we're going to use the space down here. Yeah, sorry for that. Okay, I have a space down here. Quite a big space for us to write something. Right. Let us proceed. We have a CT shall be equals to BT multiplied with the cosine of 10,000 pi t. Yeah. Okay. So the BT is based on the previous answer for the BT. We have it as equals to 5/2 cosine of 500 pi t plus 5/2 cosine of 10,000 pi t plus 2 cos of 200 pi t. So that should be then multiplied with the cos of 10,000 pi t. And as such, if we proceed with this solution, we are supposed to get 6 terms, yeah, 6 terms to be considered. So we're going to have 5/4 cosine of 9,500 pi t, okay, plus 5/4 cosine of 10,500 pi t, okay, plus 5/4 cosine of sorry, it's not 1,000, this is 1,500, yeah. Okay, it's supposed to be 1,500 pi t. Okay. So we're going to have 5/4 cosine of 8,500. Okay, 8,500 pi t. Okay, and plus 5/4 cosine of 11,500 pi t. Okay, and then we have another two, which is cosine of 9,800 pi t plus cosine of 10,000 of 200 pi t. Okay, so this is based on the operation between 500 pi t and 10,000 pi t, going to produce these two terms here. Between 1,500 pi t and 10,000 pi t, going to have these two terms. And for operation between cost of 200 pi t and cost of 10,000 pi t, going to have this operation. So that should be how we obtain these CT terms. Yeah. Okay, so from here, basically, we need to do this Fourier transform. Okay, Fourier transform for all of these terms. So the C omega. So if each cosine terms will produce two impulses, so we have 1, 2, 3, 4, 5, 6. So supposedly we are going to have 12 impulses. Yeah, 12 impulses for this particular case. In which, if we can sketch it, I think you can try to find this Fourier transform for C omega on your own. But in terms of sketching, yeah, I just proceed with sketching for all of these based on this value. Okay, we are supposed to have 12 impulses. Okay, this will be the C omega. All right, we are going to have at negative 9,500. Okay, negative, this is negative 9,500 pi. We also have at positive 9,500 pi based on this term. So the impulse amplitude will be 5 over 4 pi. Yeah, that should be 5 over 4 pi for these two. Then here we're going to have next will be this one. Yeah, after that will be 9,800. So before that we have this value. So we have quite a lot of nearby impulses. Yeah, sorry for that. This is at 8,500 pi negative. Then we have 8,500 pi positive. So that should be the impulses. Sorry for that. Yeah. Okay. Sorry for this very bad handwriting. Going to have same magnitude 5 over 4 pi. Then we have at 9,800 pi. Also at negative 9,800 pi. So this will be pi only. Okay, that should be pi only. Yeah, this is pi and this is pi. So this is dealing with these terms. So we're going to have pi only, the amplitude for the impulse. Then we have another one. We'll proceed with the 10,200. Yeah, this is the one. Also pi amplitude 10,200 pi. And here also negative 10,200 pi. Okay, having pi also the amplitude. Hopefully you can follow my sketching. Yeah. Then we have a 10,000. Sorry, not up to the scale. 500 with the amplitude of 5 over 4 pi. Okay, and then here we have also have negative 10,500 pi, which is 5 over 4 pi amplitude. Okay, so we have now we have 2, 1, 2, 3, 4, 5, 1, 2, 3, 4 ton. So another one, which is at 11,500. So we have it here. The last one, 11,500 pi. Okay, and then also here, which is negative 11,500 pi. So that should be the impulses. All right, 5 over 4 pi also. Okay, so that should be your, we call that, this is the spectrum for the C omega. So from this equation of AT, sorry, for the CT, yeah, you need to transform into Fourier transform terms. So you can do this on your own. But supposedly, you are going to have a spectrum of 11 12 impulses, which is given here, down here. Yeah. All right. Hopefully you understand about this sketching of the C omega spectrum. Any question for this? Nope. Any questions so far?
No.
Okay, hopefully it's clear, yeah? Right, and then if we base on this diagram, the C omega will be then passed through yeah, pass through the h omega. H omega is given in the questions here, which is 3 over 2, 1 minus rectangular omega divided by 22,000 pi. And the output of these filters will be the yt or y omega. Okay, so before we can find the y omega, yeah, we need to obtain what should be the pattern of the filter frequency response of h omega, which will be based on this equation. So what you have to do is you have to sketch this equation now, yeah? Yeah, have to sketch this equation now. So it is rectangular omega divided by 22,000 pi. So if I can sketch this function here, it will be look like this, yeah? This is 11,000 negative pi. This is 11,000 positive pi. Okay, this is rectangular. Omega divided by 22,000 pi. This is 1. But if we base on the overall equation here, this rectangle need to be reversed, yeah, reverse downward. And then we shift it by 1 units upright. And then multiply by 3 over 2. So end up, when we proceed with these operations all together, okay, so what I have here is the rectangle itself. The next operation that need to be done is amplitude reversal. Need to reverse it downward. Then we shift it by 1 units upward, and then multiply by 3 over 2. So with this, you are supposed to get your h omega finally, okay, h omega should be look like this. This is your negative 11,000 pi. That should be positive 11,000 pi. So you're going to have, that should be your pattern of your h omega. Yeah? H omega, this is your h omega. It should be having the amplitude of 3 over 2. Okay, so that should be how your h omega should look like. Yeah. Basically, this is a high pass filters. Yeah, high pass filters because it filter out the lower frequency. So everything lower than 11,000 pi will be filtered out, will be cut off. But everything bigger than 11,000 pi can pass through, or yeah, is allowed to pass through. So this is what we call as a high pass. High pass means that higher frequency will be permitted, lower frequency will be cut off. Okay. Okay, so if we know that the input to this filter h omega is this c omega, right? Yeah, input to the filter we have here is this one. So if we base on this frequencies value that we have and the filters respond, so we can see that everything less than 11,000 pi shall be filtered out. So based on these signals, based on these impulses that we have, we know that only 2 impulses can pass through these filters response, yeah? Which is located at 11,500 pi and negative 11,500 pi, because everything or all the others impulses are said to be lower than or less than 11,000 pi. So that is why your y omega, okay, that you're going to get will be 2 impulses only, located at 11,500 pi and negative 11,500 pi. Okay, this is the one in which the amplitude for this impulse, that is the y omega, yeah, of this impulses will be a multiplication of 5 over 4 pi and 3 over 2, which will give us 15 divided by 8 pi. So that will be your y omega. Okay, that should be the spectrum for y omega. Okay, is that understood? Is there any question for this question number 2, question 1 of tutorial 5?
Yeah, doctor.
Okay, yeah, okay, good, very good. Okay, so we have the y omega. So basically from here you can obtain the yt straight away, yeah, because from this diagram, from this sketching, you can write that your y omega, okay, your y omega is equals to 15 over 8 pi delta function omega minus 11,500 pi plus delta omega plus 11,500 pi. Okay, so you can find the yt straight away. So yt shall be equals to 15 over 8 cosine of 11,500 pi t. Okay. So that should be a YT. Right, so that answer your question number 2 just now, yeah? Um, any more questions? Yes, yes. Any questions? Okay, yeah. Hopefully you understand this clearly, yeah? All right, how about number 3? What will happen if the second modulator gives the same frequency as first modulator, which is 1000 pi radian? Okay, this is based on this. The first modulator is 1000 pi, the frequencies, and the second one is 10,000 pi. But the third question asks, what will happen if the second modulator here, instead of 10,000 pi, the value is 1000 pi. So based on what we have done so far, if the frequencies here is 1000 pi, we note that the C omega will not expand until this value, right? Yeah, everything, the values of the frequency will be much smaller than what we have here due to these frequencies which is only at 1000. So what will happen? So if that's the case, yeah, and if we base on this frequency response of your filter, we can say that all the signals will be filtered out. Yeah, nothing or no frequencies or no signals can pass through the filters. So that should be the answer for this question 3. Okay, due to the reason that the frequency is too small, yeah, it is too small, that all the frequencies or all the signals will be then blocked by the filters. Yeah? Okay, I think that's done for question 1 on this tutorial 5. Okay, hopefully you understand this clearly, yeah, on the application of Fourier transform in solving problems related to the filters, yeah. Okay. Question 2 is somehow quite similar to question 1. So can you do this on your own? Question 2, or you want me to do it for you then? Any query for question 2? Any concern for question 2? Okay, it is based on this block diagram. Okay, we are given the yt. So the output of this square law device is y2t, which is a square of y1t. Okay, and we have an ideal filter and produce the y3t. Okay, it's given the y1t is given 1 plus 2 cos 400 pi t. Okay, so what you have to do is just you have to square this. You have to square the y1t again to get the y2t based on this equation. Yeah, and then you are given the filter transfer function, which is h omega. Okay, and the rest will follow based on the questions. So can you do this on your own, or you want me to solve this for you? Hello, I'm waiting for your reply.
No.
Okay, I think you have done. You can do it on your own, yeah. Oh, you want me to solve, yeah? Okay. You Jan Xiang, yeah. You want me to solve? Let me see. This is the examples here. Okay lah. Since we have time, 12:18, still early, so I think I can solve this for you now, yeah. Right. So let's have a look at these problems. Right, you are given the yt, y1t is given here. The question is to find y2t and then find the y2 omega. Yeah? So y2t is basically a square of y1t. Y1t is given here. Okay, so basically you can write that y2t, okay, y2t will be equals to 1 plus 2 cos, okay, 2 cos 400 pi t squared. Okay, so you have to square this value, yeah? You have to square this value. So based on that, you can write that y to t will be equals to 1, okay, plus 4 cosine of 400 pi t plus 4 cos squared 400 pi t. Okay, so you're going to have, this is the result for y to t, which is a square of the y1t function just now. Right, so what we have to do now is that you have a cosine function, a single cosine function here. But for this cosine function, you have a square, right? So you have to you have to use the identity to find a cosine terms for that. So we know that a cosine square of theta shall be equals to half of 1 plus cosine of 2 theta, right? Okay, let me check. Cos squared plus sine squared theta, cos squared theta minus, okay, so we're going to have this. So you can use this identity to solve for that. So we're going to have 1 plus 4 cosine 400 pi t plus 2, 1 plus cos of 800 pi t. Okay, that should be the case, yeah? Right, so end up we're going to have 3 plus 4 cosine of 400 pi t plus 2 cosine of 800 pi t. Okay, so that should be your y to t. So based on this, can you sketch, can you find the y to omega? Okay, so you have to find different transform. So y to omega. Okay, this history is a step. Yeah, basically it's a step. So for 3, if you base on the table, let me refer to the table. If we have a DC source, yeah, a 3, that will give us 3 pi, 6 pi. Sorry, I apologize, yeah, my mistake. You can refer to the table, yeah, where we have a DC source of 3. Yeah, DC source of 3. So we are supposed to get, for 3, this is equals to, okay, let me write for you. This is a DC source, yeah, it's a DC source. So we're going to have this as 3 times 2 is 6 pi. 6 pi of a delta omega. Okay, and for this, you're going to have 4 pi. Okay, that should be 2 impulses. Omega minus 400 pi plus omega plus 400 pi. Okay, and for that, we're going to have 2 pi delta omega minus 800 pi plus, I see. My mistake, yeah, sorry for that. Okay, 2 pi. This is 2 pi, yeah? Okay, 2 pi, that should be in a bracket. And the delta function omega plus 800 pi. Okay, sorry for my handwriting, very bad because I'm using the tab. It's not convenient for me to write using this tab, but hopefully you can understand the handwriting, yeah? Okay, so this is the case. We're going to have 5 impulses supposedly. You need to sketch, right, the y2 omega. So, okay, we need to sketch it. So we have 4 impulses. I think you can sketch this on your own. You're going to have impulses at omega equal to 0. Yeah, so that should be the case. Yeah, that should be your y omega. Okay, at 0, we're going to have 6 pi. Okay, and then we have at 400 pi. We have at 800 pi. Also, we have at negative 400 pi and negative 800 pi. So for that, we're going to have 4 pi. Yeah, that's 4 pi. And for 800 pi, it is equals to 2 pi. Yeah, 2 pi. Okay, that should be the spectrum for y2 omega. This is y2 omega. Yeah. Okay. Right. That's done for the question 1. Okay. Question 2. need to sketch the filter transfer function H omega and state the function of the filters. Okay, if we base on that, it's quite similar to what we have done for the first question just now. So for the rectangle itself, we're going to have like this. Since we have 1200 pi, so we're going to have negative 600 pi and positive 600 pi. Okay, so for this overall H omega, okay, so we have a reversal, amplitude reversal, and then we have a shifting by 1 units and multiply with 0.5. So supposedly, your H omega can be sketched to be look like this. Okay. This is negative 600 pi, and that's 600 pi positive, and the amplitude will be 0.5. Okay, so that is your H omega lah, yeah? H omega. Okay, so state the function of the filters. So if you base on this filters response, you see that everything less than 600 pi will be filtered out. Everything bigger than 600 pi will be passed through or can pass through, permitted. So this is a response of high pass filters. Yeah? Okay, right, this is high pass filters. High pass filters because it permit frequencies higher than the cutoff. If the filters permit frequencies lower than the cutoff, it is called low pass, yeah, low pass and high pass. So detail of this will be done later in chapter 5, yeah, on the filters. But for now, we accept that for this particular case, since it permit frequencies bigger than 600 pi, yeah, so this is considered to be a high pass filter, yeah. Right. So that answers question number 2. And question number 3, sketch the spectrum Y3 omega. So Y3 omega is the output of the filters. So again, we have, this is your Y2 omega, the input to the filters. So we know that based on this response, 2 impulses can be passed through, which is 800 pi and negative 800 pi, in which the amplitude for your Y3 omega, if I can write it here, yeah, this is your Y3 omega, going to have 2 impulses only, which is at 800 pi and negative 800 pi. Yeah, so the amplitude will be 2 pi multiplied with 0.5. So you're going to have amplitude at pi value. So that should be the response or the spectrum for your Y3 omega. Yeah, so this is your Y3 omega, which is a result of a multiplication of Y2 omega and H omega. So that will give us the spectrum of Y3 omega. So that answer the question number 2. Okay. Is that understood for these questions number 2 for tutorial 5? Hopefully it's okay, yeah, it's understood. Yeah. Okay, so I think that's all for our tutorial session today.